entrepreneurs, mentors, investors, and industry experts. Unlock opportunities, access resources, accelerate your path to success in the space industry. It's a dynamic platform dedicated to fueling the ambitions of visionary startups, fostering collaborations, innovation, and boundless potential of endeavors. Thank you very much. Let's move on to the next session, ladies and gentlemen, which is an amazing session, and we really want to listen from our esteemed panel for the next session on how spatial insights are revolutionizing efficiency across industries worldwide. Discover how spatial insights are transforming productivity strategies across industries globally, including manufacturing, logistics, agriculture, healthcare, energy, insurance and finance, streamlining workflows and fostering economic growth. Ladies and gentlemen, please put your hands together and join me in welcoming the session chair, Professor Vinay Dadhwal, Indira Gandhi Chair, Professor of Environmental Sciences, NIAS. Welcome, sir. Can we have a huge round of applause and please welcome our panelists, Major General Sanjeev, Elena, Geosystems. Please put your hands together and welcome Mr. Shankar Shivaprakasam, founder, Eartheye Space. Welcome, sir. Mr. Vinay Simha, CEO, SkyServe. Welcome, sir. Mr. Alberto Hernando Castro, Kido Dynamics. Welcome, sir. Mr. Kunal, Raina, Head International Business and Strategic Partnerships, AxelSpace. Welcome, sir. Before I hand over the session to the chair, I request Captain Vishal, sir, MT PwC, to please join us and get ready for his keynote address. Welcome, sir.
Thank you so much. Good morning, everybody. I will not take much time before we discuss on geospatial and Earth observation use cases for various industries. What I want to cover is that where are we as we look at the Indian market in Earth observation? What are the market forecasts? What are the challenges we see? What are the key trends in this space? And I think the most important part, which are the sectors, and obviously in addition to the strategic sectors like military, is what we see the impact of Earth observation in a big way in terms of value proposition and use cases. So let me start with the market. Currently we have about $521 billion of market in India in Earth observation. Now, this market is likely to grow to about $8 billion in the next 10 years. It's a growth of 28%, and which is the highest growth. You know, if you look at the entire space value chain, upstream, that is satellite manufacturing, launch vehicles, ground systems, EO, navigation, communication, the highest growth is in the Earth observation. And let me answer the question, why is it so? Because the penetration of Earth observation or satellite imagery has not happened to the extent which it happened in the strategic sector. Not many farmers, in fact, maybe estimated it's less than 1% penetration in agriculture and Earth observation data. You compare it with the European figures, which are close to about 45% and above penetration. So those are the main reasons why it has not happened. And this is the challenge as well. How do you create demand for Earth observation and satellite imagery? And I think that's the channel will remain. The most important facet of Earth observation is it impacts close to 12 to 14 sustainable development goals out of 70. You know, issues like removing poverty, hunger, clean air, clean energy, clean water, are some of the top-notch issues which we are facing right now, and that is what EU brings in. Allocation of resources, building resilience in a society, bringing quality and safety, and that's why this is the domain in the downstream which really needs a lot of focus. Now, what are the trends? I must mention, I think the biggest trend globally which we see is democratization of data. And when we say democratization of data, data is not just the domain of the strategic sector or a select few who can afford it. I'm sure all of you know that new space policy 2023 very clearly illustrates that anything more than 5 meter resolution has to be given to every citizen in the country. So every citizen in the country will be provided data as per the space policy 2023. And it is a similar thing which we see in Copernicus program for Europe or the Landsat program in US. So democratization of data, which is important. Militarization of the space for satellite imagery is also impacted, and I think that is what we are moving from panchromatic to multispectral to hyperspectral imaging and more submetric resolution, which is going to change as we go forward. ESG, I spoke of SDG, also satellite as a service in this area, and I think a lot of people come to me, in PwC when we advise or consulting. Building satellites and building launch vehicles have very thin margins. I must tell you very frankly. It is very glamorous to make a satellite or glamorous to create a launch vehicle, a cryogenic engine, but the margins are thin. Believe me, the maximum margins are in the downstream when you play geo navigation. This is the place where when we see traction in the industry, we know that there will be more socio-economic benefits for the citizens as well as the enterprises. Now let me come to the sectors which are getting impacted. There are total about 16 sectors which we know as of now, where we have detailed use cases and value propositions in which globally which we have looked at, and obviously use cases are evolving by the day. So I just name the sectors: agriculture, forestry, fisheries, whether it's farm productivity, precision farming, fisheries, then disaster and emergency management, search and rescue, insurance, finance, banking, risk, a use case like risk modeling analysis, efficient claims management for insurance. We know of a case where somebody claimed an insurance for a piece of land which never existed. So, things like that. Transport, which includes efficient traffic management for maritime. Railways has started using it. We know the next toll gates, you will not have to stop at a toll. Satellite is being incorporated in toll gates by NHAI. Infrastructure planning, monitoring, risk assessment, consumer solutions, GIS mapping, energy and mining. And I think that's one area with many use cases. Climate and environment monitoring. I think we know what's happening in global warming. So these are some of the areas which broadly have kind of touched upon where Earth observation is having an impact other than the strategic sector. Now, what is it that we have to look at? You must go through the decadal vision and strategy paper created by InSpace, which is on the InSpace website. It very clearly lays down what are the future goals of Earth observation. Let me list down 3 of those goals. One is creating a EO platform where a public-private partnership, government invests money, and there is somebody, this PPP looks at launching satellites which are providing the data. Second is creating an EO data aggregator platform. Now we don't have anything like Copernicus in our country, nor a Landsat in our country. So what will it take for a private company to create a data aggregator platform in the space data value chain, right from the data collection to the satellites, data download to the ground segments, and coming to this data aggregation where you have storage and data coordination and aggregation, and then you have a layer of analytics, and then this data is available for various sectors. Now that's something which is also being looked at. And the last thing which also being looked at is how do you control the ground segment which is downloading this data. And till now the ground segment is only being used by ISRO. Now converting it into a managed services for the private industry, that's what we are looking at. The other important part is how do we look at the future of exports of geo data from the country. You know, these three things which I mentioned, I must also mention that how does Earth observation brings in resilience and improves the quality. In fact, I would say that we have just released this thought leadership. This will be available on the, this is essentially Earth observation, a driver for productivity, for change, for bringing in resilience, quality of life, and we released it in the morning inaugural session. I would request all of you to please download the soft copy from the website, on the website, both on PwC website as well as on SIA website in a couple of days. And you should go through, which brings out use cases and value proposition across various sectors, and especially on the SDG, which are those 12 to 14 SDG goals and how Earth observation will impact. With that, I'll just close, just make one last point. Earth observation impacts the allocation of resources on our planet Earth. Earth is a beautiful planet. How do we allocate resources? Water, minerals, air, etc., etc. And that is what Earth observation will facilitate and make this planet a thriving planet, sustainable planet as we go forward. Thank you.
Good afternoon. Today we have assembled here for a very, very exciting session. Captain Vishal Kanwar has already laid down the background as well as future. But most interestingly, the organizers have assembled such an impressive array of people, I would say, experts and visionaries in industrial domain. So I will just, introduce the names that have already been said. So we have Major General Sanjeev who would really talk of the GPS and other things. Mr. Shankar, who would really ensure that as hundreds of satellites are in space, how he can aggregate, for a specific point various data sets which will come together. We also have Mr. Vinay, as more and more satellites collect more and more information, can we really process them in space and give you the insight you want. Then Mr. Alberto not only would look at satellite, he would also look at all communication and other data and derive human-centric and continuous dynamic information for many industries. We have Mr. Kunal, Raina, who would talk about this space. So what we would really ask each of the panelists first to highlight, they are bringing new technologies, they have new solutions to enhance multiple industries, right? So Mr. Vishal Kanwar has already listed those 16 industries, right? But what these gentlemen, the panelists, are going to do, they are going to go across the industry, create new type of technologies, applications, solutions, and platforms which will enhance the EO usage. So the numbers are all there. Why do we need to focus on industry efficiency? Industry efficiency is important for youngsters to get jobs, right? Otherwise, the government always used to have some technical staff and look at what is called resource management. It really can't sustain very large number of population. But the resource management was for resource managers which were already existing. Now we are talking of moving to SDG, but then bringing in the local concerns, the local citizens, and changing the quality of life. I would really take away the time of this esteemed panel, but just point out one thing which had already been suggested. Whatever amount you work out for space economy. Launch vehicles will get 2 to 3%. Building satellite will give you 5 to 6%. 60% plus will only come from services. The communication group moved ahead and grabbed this. EO has been slow. More importantly, the EO, the emphasis towards the high resolution and military and not having enough satellite actually took away that exciting information away from the industry, and it did two things. It allowed those satellite data to be available but not good enough, right? So that is the question you have. So I will ask you just take Government of India said 5 meter and above data is free, but the government did not release a roadmap that these are the new data which we will make. Why Copernicus is so important? Because they said these are our Sentinel 1, 2, 3, 4, 5. Each one will have 2 plus satellite, and 2030, till 2030, we guarantee you free global access to everyone. Why Landsat is important? Since 1972, the entire data is not only put, but you don't really have to now download. You can go to cloud and really process there and extract information. Unfortunately, both these things we have not done in India. I think Vishal did raise the point. Can the industry do it? I'm sure the industry can do it, provided there is support. I know many people who can really build up huge data pipelines as well as the. So we will invite the panelists one by one. After they have spoken, I think they can be there itself. We would have hopefully some time to have some interaction with the audience. So let us start.
Thank you, Professor Vinay, Vishal. I'm Major Grover. I've had a lot of experience in terms of the defense applications and the utility of GIS and all. I'll just take about 5-7 minutes to highlight on the various aspects. All of us are aware of the spatial insights and how they streamline the workflows, they enhance decision making, and optimize our resource allocation. When in the field of manufacturing, you optimize your supply chain, you have your facilities put up, warehouses put up, all your industry gets very much efficient and streamlined. As far as other things are concerned, logistics, we are all very, very familiar as to how route optimization, fuel conservation, and similarly towards healthcare, placement of health centers or predicting of diseases or their treatment, resource allocation, energy, insurance, and market analysis. Well, these are not my specialities. I just jump on to my specialty, which is defense. Believe you me, when I first started about 40 years back on a small little patrol across, early morning you heard the session wherein Kargil was mentioned. Well, this is where the famous GPS or now the most popular NAVIC comes in. Positional, navigational and time synchronization has become a bread and butter for all of us. We are all well aware. We've been using GPS in almost every form in our day-to-day lives. We have suffered or we have accomplished a lot of tasks with such borrowed assistance. We are looking forward to our indigenization and we look forward to our own NAVIC coming in a big way. Towards that end, let me tell you, whenever you fire a missile, right from the data you feed in to the flight path and final destination, the entire guidance is through these spatial insights. Similarly, when you look at your line of control or you look at anything in terms of resource allocation of your defense assets, be it Air Force, Navy, Army, or even the other police forces, the spatial data, which primarily, as we are all aware, as the GIS data, the remote sensing, satellite imagery, and very loosely held as GPS data, which is now GNSS data, and spatial analysis, which takes it forward to coming on to conclusions, decision making, resource allocation, helps us a lot in our future plan. As we move forward and the other panelists speak in depth about their expertise, I am sure that space per se and the insights which we have got have contributed immensely to the defense industry, to the defense forces, to our daily warfare, monitoring, ISR, and all the aspects of security of the nation. We are also indebted to the wonderful ISRO and other international scientists who have provided these services, and more so now since the last 5 years, wherein a lot of industry has been able to take on these wonderful innovations to applications which can be applied on ground, wherein we can really utilize them on our day-to-day affairs, from our mobile phones to our movement daily schedules, to our entire industry schedules. And let me assure you that as a sector, the defense sector is a huge user and a huge beneficiary of this particular space insights, which provide us such valuable resources, which we are looking forward to for attaining more efficiency, more success, and more so we are going to make our nation strong. I pass on the baton to the next panelist. I hope I have been meaningful. Thank you.
Good afternoon. So I think Captain Kanwar, right? Captain Kanwar and Major Dadhwal probably set this up for me. So Earth observation has been the bastion of what I call the users in the top of the pyramid, which is pretty much defense. 60 to 80% of the Earth spend is in defense. They are also our primary clients from SkySpace standpoint. But I'll explain what we do. But because this session is about industry, and then Captain said, why did the penetration not happen? So if you think about why the penetration did not happen in the industry, we put it down to 3 issues. And those are the 3 issues we are solving from the SkySpace. I did come from the upstream satellites, so I do appreciate their challenges there. And now this is a downstream startup that had an upstream startup. So the problem statement about why did the penetration not happen can be put down to 3 things. 1 is the accessibility. The accessibility of satellites and sensors in space has been a problem for, like I said, anybody but those in the top of the pyramid. So how do we solve the accessibility problem? The second is the affordability problem. How do you make it affordable for a farmer or an insurance or a miner to get access to data when they need, where they need, with what sensors they need? This when, where, and what sensors is around the accessibility. With what price is the affordability? And then there's the third problem, is the usability. You could have lots and lots of data that you can access. But if you can't get meaningful information from that data that you accessed, not in days and weeks, not even in hours, but seconds and minutes, that's a usability problem. So ladies and gentlemen, those are the 3 problems we solve. And we are SkySpace, the world's largest Earth observation satellite aggregator. We are known as the Uber for satellites, or Airbnb for satellites. And there's a reason. Because that's how we solve these 3 problems of accessibility, of having, at the moment, since we founded the company 18 months ago, and I'll talk about how we are solving lots of these UN SDG issues and net zero issues In our count, we solved about 10 of the 17, but I heard Captain talk about 14. We are not seeing anybody solve a world hunger yet from it, but there could be other ways of solving world hunger from geospatial. But coming back, so we host today over 475 satellites, and that keeps growing on a weekly, monthly basis. That makes us the largest satellite operator without owning a single satellite. It's like Airbnb is the largest hotel operator without owning a single hotel room. Also, you could say of the Uber, the largest taxi company in the world without owning a single taxi or a vehicle. So that's our business model, but we made it accessible. So we brought all the sensors, everything from multispectral, the usual 5 meter, all the way down to 30 centimeter to 15 centimeter. SAR, all the way from 3 meter down to 25 centimeter. So if you want the real high resolution data, and you want to capture something as it's unfolding, a disaster, you could do it on the platform responsibly. You don't need to have any contracts. That's the beauty. So this is the idea about bringing all the different sensor modalities, hyperspectral, thermal, full motion video, greenhouse gas, you name it. So these are all the different, and then as we go on beyond the imaging into non-imaging Earth observation sensors such as RF, AIS. So we have naval customers, but I don't want to digress going into defense. But there's AIS and RF data, X-band, S-band, L-band. So these are all military application use cases for infiltration and insurgents movements. So anything from space looking down and sensing, whether it's imaging or non-imaging, it's on the platform, and it's available on subscription. And this is the best part, at $5,000 per year. You have probably never heard of this kind of affordability. If you went to any of the satellite operator and said you want to task, the minimum could be anything from 5, 10, 15,000. The previous company, I was the vice president of way back, was planned at $15,000 per single task. Otherwise, they're not interested in engaging. So $5,000 will give you access to the platform with all the sensor modalities. That's how we solve the affordability. Accessibility by getting all the sensors in one platform. So regardless of your use case, as we go into UN SDGs, whether it's about, if I were to start talking about food security through responsible consumption and production, without destroying natural habitats, including forest, right? You're going to start looking at, it's not just the multispectral that's going to do the job. You need hyperspectral, you need thermal, you need SAR, depending on the different context of these goals 2, 12, and 15. So I group them as goals 2, 12, and 15. In the interest of time, I won't say to you what those are, you can look them up. So I look them as food security through responsible consumption and production. So you need the multi-sensor approach. But if you had an issue with getting multi-sensor approach by having to go to multiple operators, even if they existed, you had an affordability problem. And then there's a usability problem, is how to actually solve these use cases by getting the information without having to have PhDs in my company. I'm an industry speak, an industry context. You're not going to have lots of geospatial PhDs sitting there and interpreting the data for you. So it has to be extracted on the fly and given to you. So that's how we solve the usability. When you task one or more sensors in the same workflow, the data gets delivered. Anything from 2 to 5 minutes, the information of interest to you get extracted from the data and given to you as a feed, which becomes actionable. In geospatial terms, it becomes a GeoJSON file. You can ingest into your own workflow. You can visualize it. It's got all the vector data of importance to you in whatever you're looking for, whether it's an object detection, feature extraction, and what have you. So that's how we make the usability across multi-sensor available. So then we move on to goals 6 and 14. We talk about water, right? Goals 6 and 14 are all about water. So how do you preserve and conserve water, which has become a very important commodity? You can't solve water issues, quality issues with just multispectral. You start, you bring hyperspectral. So how do you bring all of them in a multimodal? So the whole point I'm making is, it's a world of multimodal data that solves the wicked problems that needs to be solved to achieve UN SDG goals. And that's the kind of a platform we have enabled for industries to be able to access them with a very affordable subscription, and essentially just like you would pay Uber to come here, you pay as you task, and if you want the information also extracted and given to you, you again pay as you task. It's completely utility model. If you have a bunch of PhDs who can interpret the data and give you the information in seconds and minutes, that's what you should do. But if you didn't have it, you want the machine to give it to you, that's generated for you in minutes and seconds. And the last but least, I want to just talk about the other UNSDG goals we see in the industry context is improvement in living conditions. So the goals 3, 7, 9, and 11, it's all about sustainable cities. We have customers monitoring livability of cities. Heat is a big issue, urban heat. We have greenhouse gas issues, right? So you have landfills that catch fire in India every now and then, and has all the catastrophe that follows that. So how do you use geospatial data and sensors from space to responsibly access? So our platform is a responsive access to Earth observation data, regardless of the sensor modality, when you need, where you need, and what sensors you need. If you have a situation unfolding in the next 2 hours, we're probably the only platform you're going to be able to use to get that information because of the scale and scope of operation. 475 plus satellites will become 600, 700 by end of the year, and we'll keep being the head of the pack. So with that, I will stop my talk and then see if you have any questions to answer. Thank you.
Wow, good afternoon, and thank you, esteemed panelists here for having us here. Shankar couldn't have put the context much better. I think that from the time that we started the session, one has been raised higher and higher, saying, what can we do in EO? How can we make it accessible? How can we make it affordable? How can we make it usable in a snap? One of the challenges, I think some of the reports in industry studies, a bulk of assets that we have in space are not utilized fully. About 60% of them is where we have something that they can deliver up to, almost 40% of them don't deliver. The majority of time when we task or request for a data, it does not come on time, either it is getting delayed or it's not having the right quality. The third is, whatever assets we put in space, we can't necessarily ignore nature. About 65 to 70% of Earth's atmosphere is filled with clouds. So there's nothing called cloud-free images or scenes. Added with multiple bands, complexities, and when a satellite goes over an area of interest, and when it captures images, it doesn't even know whether it's capturing the right information from a user perspective or for geospatial needs that we have on the ground. So how do we make this smarter? Just the way we have it on our smartphones. If you take a selfie here, if the selfie is not good, we have editing tools on the smartphone itself to say, can it crop it, can it change effects, can it correct the image, and if it is good, I will start pushing it out to my friends. Similarly, when a satellite goes to an area of interest, can it become smarter to say, this image that I've captured, with multispectral, hyperspectral, factoring multiple bands, can be useful for my customers. Am I doing the right information? The bulk of the images the satellite captures today are not fit for purpose. Hence, it captures more images when it goes to an area of interest. And then, because it captures more of it, it pushes all of them to the ground station. Since it does not know which is good or bad, and then post-processing it, we say, okay, 2 of them are okay, the bulk of them are not okay. However, the cost of these images have gone exponentially because we've tasked it more, we've used the ground station resources, we've also used resources on the ground from a cloud computing. Because each of this is very, very heavy files, megabytes of data. But when you look for the information from a user, what does he want? The primary reason they want to task a satellite is, can you tell me what's happening now? Or can you tell me what's changed? If you look at it from an imagery perspective, or from SAR, or from a radar, or from an ISR related conversation. This is where we at SkyServe started looking at this problem to say, can we add this intelligence layer on board the satellites? Can we go over and see, the moment the satellite captures these images, can we figure out is it good from the user perspective or not? Can we then go back to say, can we correct this or process these images on board, leveraging existing resources or with additional computing processing that we could add there? We first went for the hardware and the software that we scaled up to work in space. Then we leveraged the existing resources on board the software itself to make that smart. The couple of missions that we did earlier this year as well is we took a satellite with our partners in Europe, what launched it in 2022. We looked at that and we pushed our edge computing solution on board. There was an uplink command. And then we started processing those images that satellite had processed, and we were able to do all of them in a couple of seconds. And then we further built out saying these geospatial applications that are using the satellite data on ground, can we make them AI ready? Can we then put these models on board the satellite itself, like a Play Store in space, kind of a model? And then we started inferring that and putting that data there so they know what the data is useful for, if they can just take an inference or part of the scene itself that they want to download, so that the cost of the solution goes down drastically. If you remember, Microsoft had this Office suite of licenses, which was prohibitively expensive earlier. Only a few government organizations had it, and bulk of the private enterprise wanted it, but could not afford it or had cracked versions of it running. But the moment Microsoft reduced the cost of the solution, bundled it with various assets like a laptop to servers and others, people were okay to pay a couple of thousands to use the original software and use it. Our aim is to reduce the cost of this geospatial data as low as possible, deliver it as quickly as possible in a seamless fashion as workflow integrated APIs to customers so that they can get these inferences in a snap. We have covered multispectral, we have covered about 150 band of hyperspectral, we have covered AIS, we have covered RF and IoT. We are integrating EO and SAR, again on the edge, to make sure that we deliver this service for the Earth observation. Our primary focus is to make this affordable, scalable, and seamless for the users. Thank you.
Hello everyone. I think that it's really clear how the technology is going. I can't add more to what is already said. Only one single layer, as it was mentioned. We are more focused on the human layer, the human activity. In addition to all this imagery of these high-resolution satellites, we also need to take care of what's going on with the human activity. I'm Alberto, I'm the CEO of Kido, and what we do is combining these high-resolution images with this human activity measured with the telecommunication networks. It's important to know that in 6G, we will be connected directly with the satellites as with our mobile phone, right? All these antennas that are now in the ground, in a few years are going to be all flying around in space. And in the same way that now we are getting these higher resolution images, we will do the same with human activity. We can see how the people is moving, how they gather, where they are moving from one point to another. And the good part of it is that there are many ways to do it private, and that's important, not being private by design in those cases. But it's all the information that we can get for that can be converted into services that helps a lot of businesses. And I think that this is an important point of the space industry, is how we transform all this technology into services, to business intelligence, and to the everyday life of everyone in a data-driven society. We have many examples of how this technology can be used. And for instance, we were talking about disasters. Recently in Brazil, we have this case. There was massive floods, the worst in 80 years, right? So we have the images, the high-resolution images on the water, how the water was growing, how the disaster was growing. But we could combine with the telecommunication network, how the people was also moving as the disaster was happening. And thanks to that, we can measure how bad was it, the impact of the disaster, and how can we help the people in order to manage that. So I think it's important to put put all this data together in order to just not having the data, having the message, but also the insights that allow us to make decisions and helping the people and helping the businesses in their business intelligence. Right? So accessibility, it was mentioned, is super important. How we can make people to access this technology. We are familiar with this technology, but probably not every business is. Some of our clients, for instance, are malls. These malls, they don't need to have a group of data scientists that know how to take this data process and use it in their business. Right? So it's important to also cover this layer of insights of all this data. At the end of the day, you use the image for something. You want to respond to some questions. You want to use it for making decisions. So this layer has also to be accessible and give the response of these questions based on this data. And with that is what we aim to do in our company, and also send that message that how the space industry can help in our everyday business, in our everyday decisions. That's basically it, because I think that a lot was said that put a good context to this layer of human activity that is the one that we want to cover. Thank you very much.
Thank you.
Hi, good afternoon everybody. I think a lot has been covered, and I think from our side, I represent AxelSpace Corporation Japan, okay? And I think one of our key motive is to make business, okay? But I think one of the important factor which we all will discuss today is industrial efficiency. And I think many people have been very focused towards very traditional industries to work on, okay? But I think with EO as a data and EO as a sector, I think it also gets into very non-traditional industries, okay? And I think my friends from PwC will agree on that I think many industries are really want to try how it can really change their business, okay? Currently, maybe it will be a secondary source of data, but how can it be a primary source of data for a lot of their decision making going forward, okay? How maybe a satellite insight can really give you an edge on how you can even become a more profitable company, how you can give some more insight to your shareholders and also give a bit more insight to people who are using your technology. I think that's also something which we do in Japan. We are a microsatellite manufacturing organization. We build microsatellites, okay, and we even host a lot of secondary payloads, primary payloads as one of our core model, and we also have our own satellite constellation where the data is getting used for Earth observation. I think what we are doing internally in AxelSpace is that not only we focus on what's happening on the downstream part of it, okay, but we also try to relate how there are people who are investing and they are also putting their thoughts from the upstream part of it, okay. And with that, we also have a right share program where people who have their ideas, people who have a specific technology capability, they can come and they can also host a secondary payload, they can also invest in our constellation, they can also be part of the whole journey, because we still see that there are people who have a specific business insight, okay, but I think they lack on maybe and hand-holding on technology base, okay. I think that's how organizations like us who have a very strong legacy and pedigree into manufacturing and who have a very strong understanding of the whole manufacturing part of microsatellite, small sat basis, they can help people to come forward on that. And I think what I also need to put a thought on is that this whole industry, I think many people when they started, or many people still see it as a very single-oriented race to win. But I think it's a game where a lot of collaboration and partnership will really turn it around on that. Yeah, if you will see other industries like automotive and all, they are very advanced when it comes to collaboration part of it. Yeah, like the same engine will be used in multiple cars in a competitor. Okay, and still they will drive their own business as part of it. I think that kind of association, which I see can be a game changer going forward. On that, that's what I think some of us in panel we work together here. And I think, and here people should really complement each other on that. I think many people are still in a race to win. Okay, they may go far. Okay, at some point of time, but I think what the need of the hour is that there are people who come with a specific know-how in a specific technology. Okay, if there are people who have a specific understanding of an industry, okay, they come together with maybe a satellite operator, then also with a very advanced platform operator, then also with a technology operator who provides edge computing, and also people like PwC who have those kind of insight, and they come together and develop a very strong offering for a full EO as a business. I think that is something which I want to touch on, and I think that will bring up industrial efficiency in a long, better way. Okay, it's not only that we need to create jobs or maybe create more opportunities in EO, but I think EO on whole has a capability to really bring on a lot of jobs across industries on that, whether it is consulting, manufacturing, or whether it is even communication, or whether it is in defense, where people are really using a lot of insight on that part of it. And I think from our side, in AxelSpace, we have a mission which says space within your reach. I think space was also very regulated. Okay, like Shankar mentioned that even here the access to satellite was very hard in some years back. Okay, now people can even get a satellite captured on a mobile phone on that. I think that's also something which is changing. Okay, and that also the push has to be done by a lot of government organizations. Okay, I think they play a very critical role when they really want to diversify a specific industry and also want to give even to a lot of private organizations. And I see with new space policy in India, a lot of push has been given to a lot of private things. I think that's also a good way where I think this is a wave. I think it's a good thing that people should really synchronize their effort in that way and see how they can collaborate and make a business with them. Thank you.
So, thank you, the distinguished panelists. We had spent very interesting, information-loaded 40 minutes from this distinguished panel. Just to recount, Captain Vishal highlighted one, the 16 industry sectors as well as the SDGs, and the future potential of EO with enhanced penetration in agriculture as the key messages. Then we moved on to Major General Sanjeev who highlighted the importance of PNT and how the GPS is a non-imaging, doesn't come EO, but for the entire security and warfare and many applications, which remains the major driver. We moved on to Shankar, who said there are many missions, many satellites, but they are neither accessible, affordable, or the information. So they have an industry solution which allows them to really garner the full potential of Earth observation. Mr. Vinay Simha talked about the edge computing so that the extra information load, the cost, and the delivery of actionable product can be hastened. Mr. Alberto highlighted it is all about humans, and they can with telecommunication and Earth observation convert it into human-oriented actions and information. And then finally, we had Mr. Kunal, who went back to satellite manufacturing. The industry as a EO with micro-satellite and advanced manufacturing and hosting other people payload, they really add to the further technological developments of EO. So we, I think, in a very short period, look not only at the current method of efficiency in the industry, but in the time to come, how these efficiencies will also be done. Also, thanks to Mr. Kunal, who pointed out that it is necessary to take this entire EO as a facilitator of economy, and SDG had already been pointed out, so that it not only supports itself, it supports many other industries. So some simple ground rule, we will invite questions, not necessarily comment from the audience. What we will do is, please stand up, identify yourself, to which panelist you are addressing, and we will take questions in groups of 3-3-3, so that we will save time and our response will also come. I invite the audience to become an active participant in this session and add more insight. I'm sure we panelists added a lot, but still there could be some gaps which you are aware of. So we go ahead, right? So please raise a hand. The organizers will assist you. Identify panelist, question or a small comment, very short. Then we will, in groups of 3, we will have response. Right.
And who can participate in it?
So I think we will answer these questions first, Alberto, then Shankar, then finally continuation.
Yes, we are operating in Europe, also in Latin America right now, and we are working with respect to India. In terms of size, what I have to say now, we are processing 250 million devices and these telecommunication networks that we combine with the imagery, right? If we arrive to India, we will talk about 400 million devices that will be analyzed. Now, in that sense, there is a lot of space in the market in Europe. It's huge. There is hungry for using this data. I would say that the market in Europe.
My question to Shankar. So the tasking is a very short time you can get the tasking. So anything is future is coming up as a predictive tasking. So similar like a disasters if you want to monitor, or if we are anticipating disasters, how quickly we can get it. So second question is how the commercial players are there. Humanity wise, so they needed to buy any satellite data. So free data. So if you have any disasters, if you have any other calamities, so the social responsibility of the private players to provide the data for the disaster managers, for the government, or to any NGOs. So any aspects is going to come, it should come. That is my point.
Right. Thank you. Who is next? Yes, Dr. Dadhwal.
I'm Dr. Dadhwal from Northeastern Space Application Center, Department of Space, Government of India. And my question to both Mr. Shankar as well as Mr. Simha. You know that now I am speaking on behalf of users basically. So very rightly you told that availability of the data, affordability of the data, and usability of the data is very, very important. And we are getting in all three. That is very clear. When I want data, data is not available. When I want to purchase the data, if data is available, I cannot afford. As a user, I am telling, not as a standard actor. And third one, how to use the data. Data is there, but users are different. There are many very, very services. So probably what Mr. Simha has told about the technology, AIs and all, that. But can you foresee next 5 years, let's say, like people are using Google Map? Can we get this data which is available, like Google Map, which is affordable, like Google Map or Google Earth, and which is usable, like any it could provide a solution for it.
Thank you, Dr. Yeah, we'll have one more question. Yes, yeah, okay. I think we will cover the ISRO. Dr. Keelan Raju is there. So we will take them together, then we will move on to the other. Yes, right.
Processing and reducing pollution, change detection, particularly encroachment of the government lands, identification, and then categorizing into what category of change.
So this is addressed to which panelist?
Shankar.
Okay. Bye. So thank you. At this point, we will, with these three questions, I think Shankar got the highest one. He would start. Then we will have maybe you want to answer, maybe Alberto. So yes.
So start with Dr. Raj's question. So we today provide automated tasking. So there are two ways of responsive collection of Earth observation. Oh, sorry. There are two ways to responsibly collect Earth observation data and subsequently get the information of interest. As I said, in a few seconds to minutes, days and weeks. So how we do that is, one is what we call combined tasking, where you task multiple sensors, either single sensor or multiple sensors, you task them together. The second one is called, which will answer Dr. Raj's questions, which is called sequence tasking. The sequence tasking is like a tip and cue. Those in military will understand this concept, where you've got two sensors to work together based on a condition being met. So the first sensor is tasked, and let's say you are looking for certain object of interest, or I think yesterday's panel, so you talked about landslide, so you're detecting some displacements or subsidence, and then automatically the second sensor, which then tends to be a very high resolution sensor, zoom into that, and that whole workflow is automated. But the construction of the workflow today, it's a human construction. So as a tasking workflow, you say, this is my first sensor, this is the condition I want the first sensor to detect. If it's detected, and that could be through an inference, a machine model inference, or it could be a business rule, and the second sensor to get tasked so that I get the complete picture. That capability is already on our platform today. But I think what Dr. Raj is probably suggesting is to go to the next level, which is machines to detect the situation and automatically task when the human is not aware. So it's the unknown unknown. So that is the sort of next level of complexity, and it is possible because at the end of the day, it's all API based. So instead of a human putting these two sensors together with a condition, separated by a condition, the machines will decide. So short answer, it can be possible. We need to know what the sort of use cases are. Potentially some of them, I listened yesterday in the disaster management context, there could be some of them where you're constantly monitoring certain hotspot areas and you detect displacement, subsidence, you automatically task. As a user or human, I didn't know about it, and now I'm being told there's going to be an impending subsidence, right? Impending landslide based on the subsidence monitor that could be down to millimeters. So that's answers the first question. In terms of social good, that's a tricky one. We are a commercial tasking company. There are monitoring missions, as you know, like Landsat Sentinel, who provide the data. We are about enabling accessibility and affordability through a price point that is truly affordable, but it's not zero, right? So I think that's going to be a challenge to get down to that expectation of being zero cost. And then coming back to your questions, I've already forgotten. Your question?
Yeah, Northeast data access.
Yes.
Along with the model to have information extraction.
Right. So
that's what I.
Okay, so I possibly already answered part of it. So you could think of the situation, the accessibility, right? Whether you need SAR, INSAR, hyperspectral, multispectral, whatever might be the data. It's available on the platform with various spatial, spectral, temporal resolutions, and you can task them together, task them individually, and when you task, and this is our secret sauce, this is the thing about usability and the time lag to usability, the latency of information has an impact on the value of the information, right? You don't want to get it after hours and days. So what we do is, while tasking, the workflow gives you a few options of various feeds, we call them feeds. Essentially, they are combining remote sensing, computer vision, machine learning models to extract that information of interest to you. And you could task one or more sensors, the data gets delivered. Thereafter, the models get applied on the data, one or more sensor data on the fly, and it requires fusion, it does the fusion. And then information of interest you get extracted and delivered to you, anything from, depending on the size of the data and the area of interest you task and so forth, anything from 2 to 3 minutes to maximum 10 minutes. We have seen hyperspectral and SAR data taking longer, obviously, but that's the level of usable information we deliver almost in real time.
Thank you. Yeah. You could answer on the encroachment urban. Then I think Captain Vishal has an overarching view on the type of questions we.
First things first, from data for social goods. We have a product as a free for use for commercial for usage called Earthsites. Earthsites looks at about 28 different parameters for climate risk, change, insurance, etc. This is free data that we're giving with 28 different indices. You just put the location, click on the indices, you get the inferences of that, and you could use that. So we built this on open source data. We've also built in more data sets. With Israel's data from NIAS, you could add more layers, give it more for commercial usage as well. The premium usage, as Shankar has also mentioned, if it's a sub-meter resolution, etc., it gets to paid usage, so commercially it will not be viable. But any free data sets that we use for common good, social goods, etc., we have ready indices that you can go to SkyServe's website today. You click on Earthsites, you have the inferences. Going back to affordability of, are we too futuristic when we talk about it? The answer is no, sir. We put across our edge computing platform stack on the existing satellite that had towards SpaceX in March. In less than 3 weeks, we put that. We were able to reduce the image compression by 5x. We were able to run the whole processing utilities in about 70 seconds. We were able to get a data product out in just megabytes or kilobytes of file. What does it mean? On a minimum average, even if you have a standard license or a premium license for the regional subscription, we were able to reduce that at least by 30%. That's our standard commitment as of today on a sensor in a resolution that's very close. If it's a higher resolution sensor with more compute power, we also know that we could reduce it much more. If you have a model today that's on the ground, that looks at disaster, that looks at landslide, that looks for rice or agriculture, etc., we are ready to take you on board, keep that model in flight on. Next year, we're doing about 15 flights across sensors. We can take you up there, you can see what the processing that we have done. You can process it at the edge itself and downlink the results. That way, the cost of data, the value of it from an end user perspective, and the latency all are answered. And we committed that, and we are already doing that. We'll be happy to chat about it after this discussion as well.
Yeah, I think
just one point I want to add. That's a good question on how you look at private sector coming in and also looking at the social benefits. And this was debated when this strategy document was created for decadal vision in the next 10 years. So if you see one of the recommendations there is creating something like Copernicus in India. So we are going to have a private entity, and I must encourage everybody here representing the private companies, the promoters, they should bid for this. This is going to be out soon. So there will be a national EO data aggregator for India, like Copernicus. And he will have rights to the data coming from the ISRO satellites, as well as from other global like Copernicus programs or Landsat programs, and private, he can source from private. But of course, data, like the space policy says, more than 5 meter resolution, he has to give free of cost to the 1.5 billion people in India and the enterprises. The moment he puts a value there, he can charge. And if he goes into submetric resolution or less than 5 meter, again he can charge putting a value there. So this will address both the needs of free and available data, and to an extent what Shankar mentioned, affordability, usability, and accessibility. But of course, there's a long way to go. We need many more satellites up in the air to have more real-time data and more, I would say, in-date data. But this is what has been thought of. So both the enterprises, the businesses in the country, as well as the society and the community will be taken care of by this national data platform.
Right, I think we covered a lot of ground. So we move on to the next bundle of 3 participants with their questions. Yeah, one at the back. Yeah, please.
Hi everyone. I am Abhinay from IIT Madras Research Park. My question is to Dr. Alberto. Your insights on carbon credit in European countries. So many manufacturing companies request you to have a carbon credit value that is brought from the space, correct? And we have a comparison on how big the market is in Europe, and to the other panelists, are we looking at carbon credit for Indian manufacturing companies? Yes, thank you.
Any other? Yes.
To Shankar sir, thank you so much sir, for joining us today.
You are the most sought after aggregator like you were.
Mr. Vinay Simha, thank you very much sir. Mr. Alberto Hernando de Castro, thank you very much sir, for joining us today. Mr. Kunal Raina, thank you sir. Last but not the least, Captain Vishal Kanwar sir.
So your insights were most powerful insights. Thank you.
I now would like to request Kaushiki Singh, research analyst, SIA-INDIA, to please join us on the stage and present a memento to our session chair, Dadhwal sir. Thank you so much sir for moderating the session. I'd like to request all the panelists to please come forward for a group photograph. Ladies and gentlemen, it's time to introduce you all to an eminent personality from APSCC who will be taking us through an exciting presentation. APSCC is a non-profit international association representing all sectors of satellite and space-related industries, including private and public companies, government ministries and agencies, and academic and research entities. Ladies and gentlemen, please put your hands together and welcome Mr. Gaurav Karol. Welcome, sir. Over to you.